Hello, everyone. Just give us a couple minutes. Want to make sure we have enough people signed in. We have over 40 people signed up for today's seminar, so want to make sure everybody has a chance to log in. So just give us a couple minutes and we'll start. All right, good afternoon. Thank you all for joining us today. We're really excited to bring back the ASHRAE New York Designer Series for 2022. We haven't done this since 2020 when the pandemic started, and we're going to make this a monthly series for the rest of the year. So really appreciate you joining. I hope it supplements our chapter meetings. We're really happy to have Charlie Jelen from Trane Technologies to present on refrigerants. And again, my name is Ben Rodney, president of ASHRAE New York for 2021-2022. I just wanted to take you through a couple announcements before we start. So and you may have seen this at Tuesday's chapter meeting, but we have launched a mentorship program. You can find more information about this on our website, but so far this has been a great success for this year, and we hope to continue this for years to come. So if you're interested, check it out on our website. This is for mentors and mentees in our ASHRAE New York network. Next month's chapter meeting is going to be back in person at Club 101. This flyer says January 18th. I need to change that. It is February 15th at Club 101, featuring Gina Bokra and Emily Hoffman from New York City, talking about New York City versus New York State energy codes, the progression of Local Law 97, changes in administration, issues they see coming down the line. So you'll see more about that coming up shortly. We do have a program on February 17th, which is in collaboration with the Building Energy Exchange. This is presented by Thomas Ye from NYSERDA, along with Dana Schneider from the Empire State Realty Trust and Michael Daschel from Brookfield Properties. So this will be an interesting presentation on the real-time energy management plus tenant program. So if you have tenants that are looking to figure out how to get support for the real-time energy management programs, this could be an interesting presentation for you. So sign up at the Building Energy Exchange website. Our next designer series is on February 24th, starring Julia Keene from Kansas State University, an ASHRAE Distinguished Lecturer. That'll be all about psychrometrics. So if you haven't brushed up on your psychrometrics in a while, this could be great for you, or if you haven't done it ever, this will also be very appropriate. So look forward to having you there at that event. And then in the vein of our theme this year, paying it forward, we do have the ASHRAE Gala coming up on May 20th. So if your company is interested in sponsoring this event and buying tickets, you can find all the information on our website. For those of you that have been to this event in the past, it is just fantastic. We're so excited to bring it back. We're also going to be supporting two community partners, Tunnel to Towers and New, which is non-traditional employment for women. plus our Distinguished Service Award winners, Gina Boker and Ed Pickenich from 2022 and 2020. So if you're interested in that, check it out on our website. Would love to have you and love your support. We're also doing the membership battle, which is a way to help grow our membership within ASHRAE New York. So basically, the companies that get the most members before the end of April are going to win free tickets to the gala. It's pretty easy. So we would love for you to participate. Check that out on our website or reach out to Anthony Montalto or Gregory Rath, our chairs. All this info is on the website and to grow our membership. So without further ado, I want to introduce Charlie Jelen from Trane Technologies to talk to us more about the future of refrigerants. And if you have questions, type them into the chat box. We will bring them up as we go. So for each section. And then for your PDH, there'll be a survey that comes up at the end. Make sure to fill that out, and then we'll get you your certificate. So when you exit the seminar, that'll come up. And then there'll be a recording available on YouTube in a few days. So make sure to subscribe to ASHRAE New York on YouTube, and you'll have access to the recording. So I will kick it over to Charlie.
All right, thank you very much. I appreciate that. You're gonna make me a presenter?
I am.
How's it looking?
Looks good.
All right. So yeah, please, as we go through this, please feel free to ask questions as they come up. There are 3 different sections that we're going to talk about, and so I'll pause in between each of them, and we can take questions as they come. The 3 areas that we're going to talk about today, specifically around this topic on refrigerants, is 1, the policy component. So what's driving this current transition that we're in right now? We're going to look at both the global transition as well as here in the US, and we'll talk specifically about New York. And then we'll get more into the actual refrigerants themselves. So what's available for current generation refrigerants, or what's available today for next generation refrigerants, and then what do we see on the horizon? And then at the end, we're going to talk about application. Some of the next generation refrigerants that we're looking at are different than their predecessors, and some of our codes and standards need to be updated in order to apply them. So we're going to talk about that as well. But before I jump in here, a little background on myself. So I'm out of our La Crosse, Wisconsin facility. I get asked this frequently based on the background. Am I in a cabin in the woods? Kind of. I've got a unique setup for this this COVID period that we're working through. My grandpa owns a farm outside of La Crosse, and this is a little 12 by 12 cabin that he let me turn into my office. I live a couple hundred yards down the road. So that's where I'm at. I'm not technically in the woods, but kind of. But it's been a nice transition. Get out of the house a little bit, still kind of close. It still feels like I'm going somewhere. Okay, my title, I'll hit on that. I'm the Decarbonization Program Manager for Trane Commercial. It gives me kind of the purview to dive into projects that are related to carbon reduction. So the 4 main areas that I typically focus in on: energy efficiency, electrification, renewable energy, and refrigerants, which is why I'm here today. All right. So the first thing that we want to hit on is globally, how are we making this happen? How are nations moving or aligning to come to an agreement to push us into this next generation world of next generation refrigerants? If you've heard of UNAPP, stands for United Nations Environment Program. And there's 2 factions associated with UNAPP that are that revolve around refrigerants. The first is on the left-hand side, and you've probably heard about this one recently in the news because of the Paris Agreement. This is related to total emissions. So you can think of a country committing to total GHG reduction. That applies to all sectors: power generation, transportation, automobiles, all of it. All right, including HVAC. And so the Paris Agreement is something that we did a little bit of back and forth on. We originally signed up for it back in 2016. We pulled out of it in 2020, and we're back in now. So the agreement or the commitment that we made for the Paris Agreement is a 50% reduction in total GHG by 2030. All right, that's a big commitment. There's a lot that's going to change at the federal level to make that happen, and refrigerants is a component of that. But the waste byproduct emissions section of UNAPP doesn't directly touch refrigerants. All right, what does, and what we're going to talk about today, is the right-hand side over here, and that's the Montreal Protocol and then the Kigali Amendment to the Montreal Protocol, which is focused in on the phase out and the phase down of high GWP refrigerants. Okay. Advance here. The background on this, so if you're not familiar with refrigerants, we've gone through two major refrigerant transitions in kind of the modern era of HVAC. The first one is over on the right here, ozone depletion potential, ODP. All right, that came about late 80s, early 90s. That was the original Montreal Protocol. All right, so we came together under the Montreal Protocol because we had an ozone hole and it was growing and we wanted to take action. All right, and I'll show you on the next slide some of the impacts of that action that we took. All right, but today we're more focused in on global warming potential. We think we have this ozone depletion potential figured out, and we moved on to global warming potential. So the refrigerants that we're using today and what we used in the past were high in GWP, and now we want to move away to lower or no GWP or low as possible GWP solutions for the refrigerants that we use in our industry. So this is an interesting graph that I like to show to give people an idea of the impact that we have as a whole when it comes to refrigerants. So the timeline here is a 100-year horizon. So 1950 projected out to 2050. And the blue shaded area is all of the ozone depleting substances that we use globally. And you can see a massive rise and increase here, right? This is consumption of these materials. So 1950 into the 90s, you can think of the industries that were booming at that time, that were using ozone depleting substances, that were using refrigerants. You think of the automobile industry, think of HVAC for sure, as well as foam blowing. So all of the panels that go into any of the appliances that you use in your house, a lot of that uses refrigerant in the background for that foam blowing. All right. But you see here, in 1987, we signed the Montreal Protocol, and the impact that had, you can see here. We globally agreed to immediately phase out the use of ozone depleting substances, and the impact was the consumption fell off the shelf, which was really good because you could see this hash line where we were headed. Right? And all the research that we have today shows that although the ozone hole, the hole in the ozone layer hasn't totally recovered, it has started to recede, and we think we're headed in the right direction. Right, but you think of those industries that were using ozone depleting substances, they didn't go away, right? We just transitioned to use different refrigerants, and they continued to grow. So that's what this next chart is we switched from ozone depleting substances to primarily HFCs, which are high in global warming potential. And so the good thing about moving away from ozone depleting substances is you can see on the right-hand side, this is their impact on global warming. Right, so they had a big impact on global warming as well. But now in the red, you can see what we're doing is we're continuing to use more and more HFCs, and now our impact on the environment is going to be significant if we don't make a change. And what we did in 2016 is we updated the Montreal Protocol with the Kigali Amendment, and it was a global phase down of high global warming potential refrigerants, right? And the hope, the Montreal Protocol, what its intent is to limit the global temperature rise by 0.5 degrees C by the end of the century. Right, so that's what we're working towards today with the refrigerants that we're using. In terms of mechanics for the Montreal Protocol, what we agreed to at the global stage, it's not a law per se. It's not like we can adopt this here in the United States or in Canada or in any country. It's an agreement among nations to lower the amount of HFCs that we use, that we produce and that we use. There is some teeth to it. So if you're a member country to the Montreal Protocol, like the United States is, and you do not comply with what we agreed to, you face trade sanctions with all the other member countries, and there's 197 of them. All right, so there is a little bit of teeth behind it, but it's an agreement among nations. Okay, what we need to do is we need to take what we agreed to, and we need to come to our home country and figure out how to make it a law. And that is very different depending on where you're at. You go to the EU, and they pass this stuff very easy. They're very aggressive and progressive when it comes to environmental regulation. Same with Canada. Here in the US, it takes a little longer to pass that kind of stuff. All right, and I'm going to talk about where we're at today in just a couple of slides. But what we agreed to is what I'm showing you on the screen here. So we agreed to a step-by-step, over time, phase down of GWP, of high global warming potential refrigerants. And it's based on a baseline. So up top here, this roughly 2,000 GWP. This is our baseline consumption for 2014 to 2015. Right? And then over time, we need to consume less and less high GWP refrigerants. Right? The first step we took was back in 2019. Right? And we met that. At the end of 2020, we were at about a 20% reduction from our baseline. But if you look out here, 2024 is a big year. We need to be at a 40% reduction from our baseline to meet the Montreal Protocol that we agreed to. Right? This 1200 that you see here, or any of these numbers, there's a little squiggly in front of it because this is the weighted average of all the refrigerants that we use. It's not saying that every refrigerant needs to be below that GWP. It's just saying the weighted average of everything that we consume needs to be below that number. All right, so that's where we're headed. You're going to see this 2024 date come up a couple more times throughout this presentation because it's a big target that we need to hit, and industries are going to need to change. Automobiles, foam blowing, HVAC, fire suppression, we're all going to need to start to change in order to hit this 2024 date. All right, so we signed this agreement back in 2016. And right after we signed it, within a few months, the US EPA tried to make a rule to help get us in compliance with that 2024 date. So there's this, as part of the US EPA, they have the SNAP program, so Significant New Alternatives Policy. It's fairly straightforward policy. All it is it's a list of end uses. So refrigerant or chillers, air-cooled chillers, water-cooled chillers, transportation, refrigerated transportation, mobile, etc. And then it's two lists: acceptable refrigerants and unacceptable refrigerants. So it's pretty straightforward. So what the US EPA did, they came out with their new rule called SNAP 21, which banned high GWP refrigerants, which included 134A and 410A, in chillers starting in 2024. All right, that was the rule they set forward. The US Court of Appeals struck it down because they said that they did not have the authority to do that. And then in the meantime, what happened is states started to pick up that ruling because it was 4 years where the federal government didn't have anything to push forward. So if we go state by state here, you can see all of these states in green have adopted that EPA SNAP ruling, which phases out 134A and 410A in chillers starting January 1st, 2024. All right, New York being one of them. All right. This is all predicated on the sale of new equipment. Right? It has nothing to do with existing equipment. If you have existing equipment that uses 134A or even R11 or 123, that equipment can stay in operation. But once you go to replace that equipment, that's when you would be subject to these rules starting in 2024 to use a next generation lower GWP refrigerant. There is one state that has gone past just chillers. So the state of California has phased out the use of 410A in unitary equipment starting in 2025 and VRF equipment starting in 2026. All right, so that gives you a little snapshot on where the states are at. If we go back up to what is the US EPA doing, under the current administration, there's a lot in process here. Okay, so we will have a comprehensive federal phase-out plan. and a phase down and a phase out of refrigerants. And there's 5 big boxes that we're going to check here in the coming years. 2 of them are done. The first one is happened right at the end of 2020, December 2020. The US AIM Act was signed, and it gave the US EPA the ability to phase down and phase out high GWP HFCs. They did not have that ability before this AIM Act happened. So that was the first step. The second step was a final rule from the US EPA on allocation and allotment rules to limit the reduction in the supply of refrigerant in the United States. All right, what that does is it's focused in at the refrigerant manufacturers. So the people that manufacture refrigerant or import refrigerant into the US, they are going to essentially cap the amount of GWP that they can sell. All right, they're going to allot them a certain amount, right? Which means as a refrigerant manufacturer, as a supplier, they could supply a low amount of high GWP refrigerant or a high amount of low GWP refrigerant. Right now, as a refrigerant manufacturer, you want to produce and you want to sell more higher quantities of refrigerant. So they are going to start to transition the industry using price. And I'll show you on the next slide. This is how Europe is going through their transition, and you'll get an idea of what that does to the price of refrigerant in the marketplace. This next bullet here is what we're more familiar with here in the US, which is sector bans. A sector ban is a phase out of a refrigerant for a specific application. All right, so chillers, that SNAP 21 rule, that's a sector ban where you can no longer use X refrigerants in X application. Right? Those are in the works right now. It looks like the US EPA will have these completed in 2022. And I've got a slide to show you where we think that's going to go. This fourth box here, HFC added to refrigerant management. If you're familiar with the EPA Section 608 of the Clean Air Act, it is a mandatory tracking of refrigerants, and there's all sorts of requirements around it. Today, it only applies to CFCs and HCFCs. It looks like we are going to be adding HFCs to that bucket as well. And then this one started out of California, but it's a mandatory use of reclaimed refrigerant, specifically around 410A. It's more for manufacturers and service providers, but we will be using more reclaimed refrigerant into the future. In terms of price allocation, all right, so an allocation rule, what it does is, right, it limits the quantity of GWP that a refrigerant supplier can sell into a market. And what this graph is showing you is at all levels, at all different levels of the supply chain, the price of 134A in Europe. And so back in 2014, that's kind of their baseline. There was nothing in place yet. All right, after 2014 into 2015 is when they signed their F-gas laws, their fluorinated gas laws. And that's when they set allocation rules. And these are the big dates. So in 2015, 2018, and in 2021, they had step downs for their allocation. And you can see the corresponding price increases around those times. All right, so the price of 134A jumped to almost 800% on the open market. And then it came down, and now it's going back up because they hit another allocation rule step. All right, so this is what we have in place in the US now, is we have allocation rules for refrigerant suppliers. So if we kind of take this chart and we think about where is this going to hit in the US, you can see this 2024 date and this 2029 date. These are big steps. And that's where allocation and allotment rules are going to have an impact on the price that we'll see for refrigerant. To what extent, hard to say, hard to predict, but very likely you will see an increase in the price of high GWP HFCs going into 2024 and going into 2029. In terms of sector bans, so phasing out of refrigerants in the US here, ASHRAE is kind of the governing body for HVAC manufacturers, and we came together, all the manufacturers in the space, And we put forward a petition to the US EPA, letting them know what dates we think the industry can realistically transition. And the dates in the bottom are what we put forward. And this wasn't just Trane, this is everybody. I'll show you on the next page who all signed it. But we think we can safely transition chiller equipment in 2024, and then unitary equipment in 25, VRF equipment in 26. The US EPA did accept this petition, and they're starting rulemaking against it. So we think sometime in 2022, we could see these dates become official, and we will have phased out of high GWP refrigerants for these specific sectors. And this gives you an idea of who all signed it. It was a lot of people. A lot of people signed this. Basically every big player in the industry. In terms of other countries, kind of a mixed bag. The European Union is ahead of us. Not a big surprise there. They're probably 5 years ahead of us on their transition away from high GWP refrigerants. Canada is pretty much in lockstep with us. They're going after a 2025 transition for chillers. And then Japan, very similar as well. They are targeting a much lower GWP level though, at a GWP of 100 by 2025. So in general, if we build this out, kind of give you a snapshot in time where we're at. So we used to use CFCs, R11, R12, R22, transitioned away from those because of ODP. So the bucket that we're kind of currently working in, kind of transitioning out of, is R123, 134A, and 410A, HFCs and HCFCs. The next thing we're going to see is likely two different buckets of low GWP refrigerants. There's this bucket of lower GWP, which gets you to this less than 1300, but not all the way down below 300, where we think we're going to need to be long term. Right? So we'll show you the refrigerants that we in the coming slides here, what refrigerants we have available in these different buckets, either lower or low GWP. But as we project forward, is there going to be another transition away from what we see? And it's hard to tell, right? That's something that as we move forward, it's going to be a kind of a year to year or every couple of year audit. How are we doing against our plan? And if we look like we're doing well against our plan, maybe we won't see another transition of replacements for 410A. But if we need to reduce further, we could see another transition out in the future. So I'm gonna stop there. Were there any questions to this point, or I can't see the chat?
Well, there haven't been any typed in. So
Okay.
just let everyone know if you have questions, please enter them in the question box and we'll answer them in real time.
Very good. All right, we'll move on to the next section. This is usually where people are most interested anyways, is what do we have available? And when we bring our industry, when we bring a new refrigerant to market, the stuff on the right is a subset of what we need to consider when we bring a new refrigerant and a new product to market. You see the tagline at the bottom. There is no perfect refrigerant. There never has been a perfect refrigerant in our industry. If there was, we'd be regulated to use it. So in the absence of a perfect refrigerant, what do we rely on? It's balancing critical factors. And the factors that usually come up as the most critical are the three that we show here. The environment's really pretty easy, right? That's the reason we're transitioning. We're trying to use the most environmentally friendly refrigerants as possible, right? Knowing that there isn't a perfect environmentally friendly refrigerant out there. All right, safety is a big one, especially for some of the reasons we're going to talk about next. And safety is twofold: for the technicians that work on the equipment, as well as for the building occupants where the refrigerant resides.
Charlie, can you go back to the previous slide real quick? We have a question we have a question from Chris asking, what about R744, i.e. CO2? I think in relation to this slide.
Yeah, CO2, natural refrigerants we get asked about quite a bit, continuously in call it R&D. We would like to use natural refrigerants where possible, But when you look at the bigger factors that we need to weigh, namely efficiency and safety, a lot of the natural refrigerants start to fall off. So I'll give you the quick natural refrigerant overview here. There's 3 that typically come up: propane, ammonia, and CO2. Propane is highly flammable. We see propane being used in our industry in extremely low charges. So you'll see propane and isobutane being used on like small refrigeration circuits for refrigerators or freezers, or maybe even like some small window units, window air conditioners. But putting large quantities of the propane into big built-up equipment, that's a tough proposition because of its flammability. Ammonia, similar, it's flammable, but it's toxic as well. So again, putting that into a building is hard when we look at the safety aspect of it. We do use ammonia in our industry, primarily in the process side where it's not populated or the occupant density in those factories is fairly low, and in specialty applications. And then the other one is CO2. CO2 has some potential. CO2 as a cooling refrigerant is not the best. It operates at a really high pressure, and some of the properties of CO2 don't lend itself well for cooling applications. But CO2 does have potential as a heating refrigerant. And I'm sure in this audience, the electrification of heat is not a new topic. So using heat pumps with CO2 is something that some manufacturers are bringing product to market, but primarily as direct or dedicated heaters. So with most heat pumps, they reverse. They do cooling and heating. If you design that with CO2, you'd get decent heating performance, and then you get really bad cooling performance. But if you look at applications where you only need heat, all right, so the first one that pops up for most people is domestic water heating, right? Those systems are heating only. CO2 is a viable refrigerant in that type of application in a heat pump. So I haven't included it on here, but definitely something that I will in the future to call out. So yeah, CO2 is a refrigerant that we will be looking to use into the future, both now and into the future.
That's great. We're starting to get some more questions. So there was another question about CO2 refrigerant, and then we'll jump to Joe's question. Mariana is curious, what does high mean in terms of pressure in the context, I believe in the context of CO2?
Sure. It depends on your operating conditions, but let's just say generically, you're 1,000 PSI, maybe more, and a 410 circuit would operate at 200 PSI, something like that. So a couple orders of magnitude higher.
Great, and if that didn't answer the question, just let us know in the question box. And then Joey had a question, will any of these refrigerants be a drop-in replacement for R410A?
Great question. We'll talk about that in the next couple of slides.
Okay, thanks.
All right, so one of the things on this chart that we've never had to deal with, but we will have to deal with in the future, is flammability of our refrigerants. Flammability isn't new for our industry. We've been using natural gas for a very long time. So we know how to handle the flammability characteristics in our products, but it's new for a refrigerant, which means we have to update stuff. If you look on the right-hand side, these classes, we used to have just class 1, class 2, and class 3 for flammability. Class 1 is non-flammable. Class 2 is, it's called lower flammability, but this is where like diesel fuel resided, ammonia resided. Class 3 is propane, is gasoline, stuff that explodes. As we were going through, and ASHRAE Standard 34 is the standard responsible for classification of refrigerants, as they started to analyze some of our next generation alternatives, namely for 410A and 134A replacements, some of them started to fall into a flammability category, but they were on the low end of class 2. So what they did is they created a new class called class 2L, and the tag they put to it is difficult to ignite and sustain a flame. All right, so it's this in-between category, which is great. The problem is now all of our standards and codes need to be updated to reference this new category, and then we need to figure out how to safely apply this category in our systems and our buildings. So that's kind of the transition we're in now, and I'll talk more about that at the end of this presentation. But this is the chart that kind of gives you the full landscape of where we're at for transition here. A lot on this chart, and we're gonna walk through it piece by piece here. At the top, you'll see 3 big sections, and this is primarily how we segment our refrigerants in our industry. So low pressure refrigerants, medium pressure refrigerants, and high pressure. The refrigerants typically lend themselves to a compression technology. So low pressure is centrifugal compressors, medium pressure is both screw compressors as well as centrifugal compressors, and then high pressure is scroll compressors. All right, so that gives you an idea of application size as well. Okay. Let's start on the left-hand side here, low pressure. The top bar chart is showing you COP, so how efficient is just the refrigerant, comparing apples to apples, just the refrigerant. And then the bottom is the GWP, the global warming potential. Okay. You can see R11 is the most efficient refrigerant we have ever used in our industry, kind of across the board here. Unfortunately, it has a really, really high GWP, and it ate ozone for lunch. So we moved away from it, and we moved into R123, which we moved away from in 2020. And now there are 2 refrigerants available as replacements for 123. So they're 1233ZD and 514A. As we get into these new refrigerants, you know, it looks like a mess, right? We're adding more numbers, we're throwing letters on the back. Some of them are capital, some of them are not. There is a decoder ring for this if you really want to geek out on it. Every digit means something, every letter means something, whether it's capital or lowercase, it all means something. One thing I'm going to call out is just the first number. If the first number of the refrigerant starts with a 1, 2, or 3, it means it's a single molecule. It's the only thing in that refrigerant. If it starts with a 4 or a 5, that means it's a blend of multiple components. Right? Typically, we lean towards 5 series blends because a 5 series blend, although it is made up of multiple components, it acts like a single component. Okay? 4 series blend have what we call is glide, and glide means that at specific pressure and temperature, the components inside that blend start to pull apart. That's not a problem on the design side. We can design systems to handle that, but it becomes an issue on the service side because if you lose some refrigerant through operation, you don't know how much of each of those components you lost. So you end up having to pull the entire charge, putting virgin charge back in. Okay. So just a little note there when you see 5 series and 4 series blends. All right, in terms of the low pressure space, this is really the bright spot for the industry right now. We have 2 viable commercially available refrigerants. Both of them are efficient in terms of their predecessor as well as overall for the industry. And their GWPs are ultra low, 1 and 1.75. These are extremely low for what we're looking to get to. In the medium pressure space, we use 134A today. We are going to move away from that because of its GWP, 1300. And there's a couple of different candidates, right? The 513, 515B, and 1234ZE. Okay? If you look at their GWP and their efficiency, on paper, 1234ZE is the clear winner, the most efficient with the lowest GWP, but it falls into that 2L category. Right, so the reason that we're not seeing this 1234ZE in commercial applications in the US today is because we need to wait for our codes and our standards to be updated in order to safely apply those products. All right, so manufacturers will start to produce product with this refrigerant here in North America once we get all of that solidified and once the demand starts to grow for it. Right? But in the meantime, we'll be looking for non-flammable replacements for 134A, and there's 2 of them, 513A and 515B, and then you see their corresponding GWPs. Okay, this refrigerant, right? If we think about that phase down chart long term, by 2036 we want to be at a a weighted average of 300 for our total consumption of GWP. This refrigerant here, 515B, was formulated to get to that 300 level, because if you're under 300, you're likely safe of future regulation. Okay, so this 513A is potentially a long-term solution, depending on what else we use in the industry as a whole. But there's still a little bit of risk there long-term. Whereas if you get down into the single digits or under 300, probably a little safer. Right? High pressure world. This is the least on the least solid ground today. Okay. 410A is what we use. It's got a high GWP. There are 3 solutions that have been pulled forward as replacements for 410A: 466, 454, and R32. All right, you can see 454 and R32 both fall into that 2L category. And then at the bottom, you see their GWPs. 454B has the lowest of the alternatives. 466 and R32 pretty similar on the higher side. Typically, we can look to Europe and Asia and get an idea of what's coming our way, because usually there's only one refrigerant that's going to replace 410A, right? Because it's used extensively in residential equipment and all of our unitary equipment. It's a high volume. Typically, we're only going to see one replacement for it. We're seeing a mixed bag coming our way, right? There's 454B is being used in Europe, and R32 is being used in Europe and in Asia. There's pros and cons for all of these refrigerants, and time will tell where we go. And it might be multiple refrigerants to replace 410A into the future. Right now,
Charlie,
go ahead.
I'm sorry. Yeah, no, finish, and then we got a few questions.
I was gonna say is today in North America, there isn't an option to replace 410A in most of the equipment, in 99% of the equipment that's out there. So if you have a rooftop unit and you want to replace it today, 410A is going to be the replacement. The first hurdle for 410A is in chillers starting in 2024, but the bulk of 410A is used in unitary equipment, smaller unitary equipment, and the first hurdle date regulatory wise is 2025. So there is a little bit of time in terms of having product available from manufacturers in our industry, but we don't know what refrigerant is going to be used next extensively, and whether or not there's going to be a mixed bag. Sorry, go ahead. What was the question?
All right, great. So we have a few. So this is from Eric. So can you please discuss some applications that may put 134A in scroll compressors, and why a piece of equipment would do that, or why you would do that in a piece of equipment?
Great question. And there might be more. I'm not saying I know every application, but where I've used 134A in a scroll compressor is when we need to get to really, really high condensing temperatures. So let's say you want to do an electrification job, or you want to start to decarbonize that building. You want to offload some of the boiler load, offset some of the natural gas consumption. That boiler is likely selected for 160 to 180 degrees. And if you want to add some electrification to that building, you'll likely need to get up to those temperatures. And a lot of the heat pump technology is fairly limited in terms of high-end capability today. But if you put 134A into a scroll compressor, you can get up to 160, 170. I've even seen some up to 180 degrees. And so that's where I've seen 134A being used in scroll. Hope that helps answer that question.
Great. And Eric, if that didn't answer your question, let us know. This is from Chris. Do you know of any progress in New York City to update codes to allow A2L refrigerants to be used in buildings?
Great question. I've got a slide for that coming up. So we'll
wait for that. And then I think you might have answered this question, but there was a question about R1233ZD is lower target, low GWP of 300. And should we conclude that systems such as VRF should be targeting this refrigerant in the future? Same for R14A. but it's possible that they need to be high pressure. So I was wondering if you might be able to address that.
Yeah, good question. If you look at the page here, you would say, well, why don't we use 1233ZD and 514A, which are really high efficient and ultra low GWP? Why don't we use that for everything? And the reason is it's a low pressure refrigerant, and so it's hard to use these types of refrigerants in scroll compressors, just the way that scroll compressors are constructed and the characteristics that we're looking for there. These refrigerants are primarily used in centrifugal chillers, which puts you into typically larger pieces of equipment, you know, hundreds of tons of cooling and heating capacity. So yeah, they'd love to use them, but it just doesn't lend themselves to the type of application that we need them for.
Okay, that's all the questions. We do have over a 90% attentive rate, so it's great.
All right, very good. So this next section here, and I've got 15 minutes left, perfect, is about the application of 2L. So we're going to focus in on that layer here. So if we go back, if you wanted to apply 1234ZE, if you wanted to use 454B or R32, how can I do it? What can I expect to see in the future? Okay. There are three big standards that need to be addressed, as well as SNAP approval. Okay, so ASHRAE Standard 34 is classification of the refrigerants. ASHRAE Standard 15 is application safety, so how to safely apply the refrigerants in the equipment. And then there's a product safety standard from UL, which applies to the manufacturers more so than designers or owners. All right, so that's one that we need to worry about. So all of those get referenced in your local code, whether it's IMC or UMC. And then on top of that, we also need that SNAP approval. I talked about this at the beginning, significant new alternatives policies. So that's that list of acceptable and unacceptable refrigerants. Right, so if we have all of this wrapped up, we can apply 2L refrigerants in buildings today. Okay, the problem is we're all over the map on adoption here. So I'm going to walk through this. There's a lot of colors here, but hopefully this will start to make sense. Okay. Legislation passed. So this legislation is states are going after legislation that says, I've got the code, I've got the line in here, that local codes cannot prohibit the use of SNAP approved refrigerants in listed equipment. Okay, what that legislation that some of these states are passing, what that's doing is just saying, if the US EPA has approved the use of an A2L refrigerant for a specific end use, say unitary equipment or chillers, the local code cannot prohibit it. All right, you can imagine the mess this is going to cause at the local level. All right, where this is going to be really, really interesting is in these yellow states, and thankfully there's only one. All right, because in Texas they've passed the legislation, but they haven't updated their codes yet. So they could use 2L refrigerants, but their local code still says you can't, or their statewide code says you can't. So that would be a mess to try to sort out. Okay. There are two states, Washington and Oregon, that have passed both the legislation and they've updated their codes to adopt 2L refrigerants. Okay. There's a handful of states, and so these are the ones in the blue that just went straight to updating their codes. They didn't need to pass the legislation. They just went straight to code adoption. Right? And so you can see them in blue. Right? In all three of these colors, so in yellow, light green, and blue, we can sell, we as the industry, we can sell and apply A2L refrigerants today. All right? If the product's available from a manufacturer. In 2022, this year, you can see the states in orange. Those are states that have signaled something that looks like they might go after that legislation as well to allow A2L refrigerants. Okay. You can see New York. You can see New York's not on there. I'm not familiar with where they're headed. I know there's a stretch code that might include some of this language around A2Ls, but I'm not exactly sure. If there's someone on the call that does know where the state or the city stands on A2L refrigerants or on 2L refrigerants in general, please share with the audience here. But that's where we're at. There is one other thing, that there is still a workaround here if you want to apply a 2L refrigerant. Okay, so all of these states in gray can still use something called alternative means and methods, which is a project by project workaround to petition the AHJ to allow the project team to use updated standards from the code cycle they're currently working off of. That was a lot of words. Let me show you what that means, right? So this is, we're gonna focus in, and I'll send this deck out so you can have this as reference. There's a lot of information here, I get it. So this is using a 2L refrigerant, slightly flammable refrigerant, in air-cooled chillers. Okay, first thing, are they SNAP approved? Well, one of them is SNAP approved. 1234ZE is SNAP approved. R32 and 454B, not yet, but we fully expect that they will be. Next, we need to look at the code path that you're on. You know, which year UMC or IMC are you referencing? Okay, if you're, let's take for example, the local code is referencing ASHRAE or the UMC or IMC 2015. You would need to use alternative means and methods, which is petitioning the local authority to use these updated standards. Okay, UL, bunch of letters, 2-40 edition 2, ASHRAE Standard 15 2019, ASHRAE Standard 34 2019. This is a request. It's a paper hurdle to get over, and technically speaking, the local authority could deny it, right? I haven't seen that. We've used alternative means and methods in the past for various things, specifically around refrigerants, and it's gone through every time. But there is a possibility that they could say no. Now, as these code cycles continue to update, as you move forward in time, you get out to the 2021 code path, and it's incorporated all of the correct standards for using 2L refrigerants in outdoor chillers. All right, so then we would just need SNAP approval at that. All right, so it's just kind of, as we move forward in time, it gets cleaner and cleaner. But if you're on an old code path, it becomes a little bit of a mess and a little bit of a paper hurdle to come over. All right, and again, this is a project by project requirement. It gets really messy when we get out to VRF and unitary systems. Even the 2021 code cycle does not have the proper references for standards and codes, or just standards. So again, I know that's kind of a lot. There's a lot of confusing stuff in here, but I will send these slides out for reference, and hopefully they help if you need to look back at it. The last thing I want to talk about is ASHRAE Standard 15 and some of the updates that they made in the 2019 version, specifically for two different system types, direct systems and indirect systems. And it revolves again around these 2L refrigerants, slightly flammable refrigerants. So in ASHRAE 15 2019, what it says for unitary equipment, unitary and VRF, is you need to have a factory mounted refrigerant detector at every evaporator coil, which is a big change. So if you're going to use a 2L refrigerant, slightly flammable, you need to have a refrigerant detector at every evaporator coil. Okay, so that's a big change. And then the second one here is kind of a no-brainer. If you're going to use a slightly flammable refrigerant, you can't have ignition sources in the ductwork. On the mechanical room side, so indirect systems, these have made some big changes here. They changed the way that they're going to do refrigerant detectors. You need to have remote control at the exit of every door to a mechanical room. And multi-port detectors are not going to be allowed anymore. And then the big one down here is ventilation rates. You can expect, right, flammable refrigerant, you're going to have more ventilation, but the numbers that are there are large. So for example, if you switched from a 134A chiller plant to a slightly flammable 1234ZE chiller plant, you would have to increase your ventilation somewhere 3 to 4x. Right? That is a lot more CFM that you need to bring into that space. If it's new construction, that just means bigger ductwork, bigger air handling units, bigger louvers, fans, can design around it. If it's existing mechanical rooms that you're trying to retrofit, that becomes a challenge. Trying to fit 4 times the CFM through the ductwork, it's going to be a challenge for a lot of installations. So more to come there. That's going to be a hurdle to overcome. All right, last slide here, and then we'll open it up for some final questions. Again, there is no perfect refrigerant. It's about taking that balanced approach for the jobs that you and team are working on, balancing safety, environmental impact, and efficiency. Leak tightness moving forward is going to be key, right? If you don't lose refrigerant to the atmosphere, you minimize the impact on the environment that you're going to have. All right, so above all, if you're leak tight, you're going to have a lower impact on the environment. As far as transitioning today, if you have a centrifugal low pressure application, we have alternatives in the industry. So low pressure centrifugal alternatives, kind of that bright spot, they're there, high efficiency, low GWP available today. Medium pressure, we have some available, but not all the way down to that ultra low yet. Those are on the horizon. And then high pressure, kind of that unitary space, scroll compressors, that's a little bit of a mixed bag, kind of a wait and see where the industry goes there. And that's all I had. So any more questions there?
I don't have any additional questions in the chat box. Does anyone, we'll give everybody another second, do you have any additional questions? Okay. Well, I want to thank everyone for coming. Charlie, that was fantastic. I want to sincerely thank you for everything. I'm going to take the screen back for a moment.
Go for
it. Here we go. So, whoops. Okay, so just want to remind everyone, so we have a couple events coming up. The RTEMS event is coming up next month, so make sure you sign up for that on the Building Energy Exchange website. We have our chapter meeting coming up next month as well, in person, Club 101. Look forward to seeing you there. That should be great. We do have our next designer series on February 24th, so make sure to check that out on the website. And then the PDH survey should come up when you log out of this, so make sure to fill that out. Recording will be available on YouTube, so make sure to go to YouTube and subscribe to our channel, and then you'll be notified when it comes up. I will try to get the deck out to everyone here along with the survey. That might not come immediately, so we'll get that out to you. And then if you need to contact ASHRAE, just email us at ashraenyc@gmail.com, and we will get back to you. Actually, Charlie, I see one more question. Given the requirements for refrigerant leak detection at each evaporator, do you think the more viable path forward is for central equipment / air-to-water heat pumps with water source heat pump terminal equipment? And this is kind of in reference to it might be expensive to do the detection in each evaporator.
Yeah, you look at the total cost of a project. I doubt that the evaporator coil, the refrigerant sensor at the evaporator coil is going to swing a job one way or another. It's just another point that you need to consider. But I don't think it's going to swing that many jobs. I think there's going to be the requirement for a high volume of those refrigerant detectors. So I don't think the cost is going to be prohibitive. And there's potentially changes. So as ASHRAE Standard 15 progresses, there could be changes that limit the impact, limit the number of refrigerant detectors, maybe by room size, various things like that. So I don't think it's going to have a big impact on which system you choose.
Great. All right. Well, again, we really appreciate your time, and I'm sure all the members of ASHRAE New York thank you. So appreciate it and hope to see everyone again soon.
Thanks for having me. Appreciate it.